There is a lot of vocabulary that we use when we're talking about polynomials. In fact, a lot of the language that we use in algebra was invented to talk about polynomials, and everything else just comes along for the ride. So if some of the language gets confusing when we're not talking about polynomials, that's why. Unfortunately, that means that at this point, we just kind of have to slog through a wall of vocabulary. So this is the first of two videos slogging through the wall of vocabulary around polynomials. We talked about the degree of a monomial earlier. The degree of a polynomial is the highest degree of any term. So the largest number of variable factors in any term. The leading term of a polynomial is the term with highest degree. Whatever order the terms are written in, the highest degree term is called the leading term. And the leading coefficient is the coefficient of the leading term. If there's more than one term that has the highest degree in the polynomial, then we don't say that it has a leading term. So let's see an example where we just work with those terms in our vocabulary. For each polynomial, we're going to identify the leading term, identify the leading coefficient, and find the degree. So to identify the leading term, we need to look at the degree of each term. So the degree of this term is 3, right? We have just x to the third. In this term, we have degree 2. In this term, right, this is x to the 1, so we say we have degree 1. And this is a little bit weird, right? We have no variables here. Well, no variables, that's 0 variable factors. That has degree 0. The term with the highest degree is this first term with degree 3. And so our leading term is that whole 3x to the third. The leading coefficient is the coefficient of that term, 3. And the degree of the entire polynomial is the largest degree of any term, which was also 3 because we had x to the third there. Okay, next polynomial. So our first term, we've got just x, that's degree 1. 2/3 x to the third, that's degree 3. 7x to the fifth, negative 7x to the fifth, that's degree 5. And so since this has the highest power of x, our leading term is negative 7x to the fifth. Notice that the negative sign stays with that 7. Right? Subtraction is really, in disguise, adding a negative. And so our leading coefficient here is negative 7. And the degree is the highest degree of any term, 5. Okay, these first two examples, there was only one variable. And that made the degree easy to figure out for each term, because we just had to look and see what is the power of that variable. In these next two examples, we have more than one variable. So to figure out the degree, we need to add up the powers of all the variables. So in this first term, we have 3 times x squared times y. So our degree is 2 copies of x plus 1 of y is 3. In this term, we have 4 times x times y squared. So our degree is 1 copy of x plus 2 copies of y is 3. And then in this last term, we have 2 copies of x and 2 copies of y. And so our degree is 2 plus 2 is 4. This last term has the highest degree of any term. 4 is the highest. And so our leading term is 1.3 x squared, y squared. The coefficient of that term is just 1.3. So our leading coefficient is 1.3. And the highest degree of any term is 4. So the degree of the whole polynomial is 4. In this last example, we have x squared. So this term has degree 2. We have x times y. So this term has degree 1 plus 1 is 2. And then we have y squared. And so this last term also has degree 2. In this last example, all of the terms have degree 2. There is no single term with the greatest degree, and so there is no leading term. So I'm writing NA for not applicable. You could also just write the word none. That would be fine. The leading coefficient, also not applicable, or we could say none. But there is still a degree, right? There are terms with degree 2. The highest degree of any term is 2. So this polynomial still has a degree 2. That's why we say the degree of the polynomial is the highest degree of any term, rather than saying it's the degree of the leading term. Even if there's no leading term, the polynomial still has a degree. So that's one term, leading coefficient, degree of the polynomial. Another way to describe the polynomial is based on how the variables appear. If only one variable appears in the polynomial, we say it's a polynomial in one variable. If several variables appear and every term has the same degree, we say it's a homogeneous polynomial. And the reason that we give names to those two things is that polynomials in one variable and homogeneous polynomials turn out to be the easiest ones to work with. So, very briefly, let's identify some polynomials as falling into one or another or neither one of these categories. So this first polynomial, we see that the only variable is x. This is a polynomial in one variable. To find the degree, we just need to find the largest power of x. So the degree of this polynomial is 4. This next polynomial we see contains more than one variable. So that is not a polynomial in one variable. To see if it's homogeneous, we look at the degree of each term. And it's easy to see the degree of the first term is 2, and the degree of the last term is 2. This middle term has degree 1x plus 1y, also 2. Every term in this polynomial has degree 2. So we say this is a homogeneous polynomial of degree 2. And finally, this last example, again, has x and y, so it's definitely not a polynomial in one variable. This first term has degree 1 plus 1 is 2. The second term has degree 1. This third term has degree 1. So we have a term with degree 2 and two terms with degree 1. So that polynomial is not homogeneous. It falls into neither category. We can still say the degree of this polynomial. It's the highest degree of any term, which is 2. We can write the terms of a polynomial in any order. Addition is commutative. However, often it's useful to organize a polynomial in one of two ways. We say a polynomial is written in descending order if the terms are ordered from highest to lowest degree. A polynomial is written in ascending order if the terms are ordered from lowest to highest degree. And notice that this is most useful with polynomials in one variable, since if we can't combine like terms, then every term has to have a different degree. So here we have an example polynomial where the terms are all jumbled up. We'd like to write it in descending order. So we look at the degree of each term, right? This is degree 1, degree 2, degree 3, and degree 0. So the highest degree term is this negative 2x to the third. 3 is the largest degree. To write in descending order, we want that first. So we'll have negative 2x to the third. And then we have a degree 2 term, minus 3x squared. And then we have a degree 1 term, so plus 5x. And finally, our degree 0 term, plus 6. So in descending order, we have our degree 3, our degree 2, our degree 1, and our degree 0. In this case, the degrees come one after another, 3, 2, 1, 0. There can be gaps in the sequence of degrees, but we can still write in descending order, largest first. We can also write in ascending order, smallest degree first. So here's another polynomial where the terms are all jumbled up. We have a term with degree 1, a term with degree 0, a term with degree 5, and a term with degree 7. To go in ascending order, we want to start with the lowest degree term, which in this case is the degree 0 term. So we start with 15, and then 0, 1. Next we'll have our degree 1 term, 5y. And then we don't have a term of degree 2, 3, 4. Next we want our degree 5 term, minus 6y to the 5th. And then we don't have a degree 6 term, so last we'll have our degree 7 term, plus 2y to the 7th. So that's ascending order, lowest degree to highest degree.